Control, that is Hercules going past the transom.
Control copies past transom.
Control deck, that is tether all out.
Control copies tether all out.
Sounds fitting.
Control deck, that is Atalanta in the water and away.
Control copies Atalanta away.
Hercules is dive, dive, dive.
Is Elani there? No. No. Elani, she's not there. No. Oh. Squid attack.
Is the upper or lower camera able to be on, or is that later?
Control, winch. Control, winch.
Yeah, I can't even see him.
Go for control.
We're all stop 49 meters. Are you ready for control?
They're so entertaining to watch. So busybodies. That one's not camera shy. Look like a
This is
Fusilia.
a audio slate for dive H2074. UTC
There
time
we go. Can you hear me now?
is
Yeah.
11:24:55. Mark.
Ooh. Oh, this is cute.
Oh. Hey, Max, you want to zoom on the squid?
Look at the eyes.
So cool. Hey, Max, can you hear me?
No.
Max, can you hear me? Zoom on some of these fish when you get a chance, man. Or that siphonophore.
That would be an ROV call.
Oh.
For
Oh,
a
okay.
zoom.
Those are jacks right there. Probably Decapterus.
Were those like flashlight fish or something? Really?
No, those are jacks. Those are shallow
Jacks.
water fish.
Okay.
Oh, look at that school out there. Oh,
Are they fish?
yep.
Yeah.
Can we zoom? They're gone.
Bye. They might be back.
Yeah. Sorry, Jeff. Just want to.
Squid.
Squid attack. What's that?
Oh, can we zoom on that?
What is that?
That was a siphonophore with all its tentacles retracted.
Oh.
Here. Hey, what's going on? Thanks, Dan.
Can we zoom the camera from time to time?
Which camera are you talking about?
The main.
Sorry, say again?
The main, the HD. Just to look at some of these squid and fish.
Oh,
and
yeah,
like that.
yeah. Sorry. Let me get present here on this dive. Yeah. So. Yeah.
There's so much stuff.
Yeah. Okay.
Does that mean go for zoom?
Oh, what do you want to zoom on? Like, what's
don't know.
the plan here?
Well, things rapidly enter the field of view. Siphonophores, squids, fish, and we thought maybe we could just zoom in and out. Figured it probably wouldn't interrupt with anything you were doing, but weren't sure about that.
Yeah. So. Let me do some things here real quick.
Okay.
So that maybe I can help you.
What's that? Another
right there.
siphonor?
Don't know what that was.
Because like if I'm set up properly, I can help line up shots.
Cool.
Okay, so Jeff, for this descent, let's give it a try with you calling the zooms to directly to video. Video, is that okay if you get your zoom direction from Jeff?
Absolutely.
Okay. And
oh, the power.
Yeah. If you abuse this power, I will take it away from you.
Knew that was coming.
No, I know you're good for it. Yeah, okay. And
oh, right there, zoom.
Kind of.
Some sort of shrimp.
Okay, go wide. And then I'll try and...
Oh, eel on the left.
Are you serious? Are you just making things up?
No.
I'm not even sure the
I
camera zoom
didn't
is
see
fast enough.
anything.
Oh.
Who put Jeff in charge?
Okay, if I'm going to play this game, it's going to be a little on the distracting side, so, okay, sounds good. This guy?
Sure.
I'm just gonna crash zoom on these. I don't know.
Yeah, absolutely.
Yeah, I mean, you have to be fast because they're only going to be here for a few seconds, but...
Okay.
Yeah, and when you go out, go all the way out, just like you did, so that I can see the vignetting. It'll help me
Oh, okay.
figure out where the camera is again.
Totally. Apologies to any viewers who are prone to motion sickness.
And you're trying to get an ID on
Yeah,
some
like
of these.
this fish right here on the right. Oh, suggested shrimp.
Oh.
Oh, I don't know what that is. It might be a lanternfish.
Okay, go wide.
So hard.
Yeah, this is going to be very challenging.
Yeah.
But the suggested shot was great.
Cool.
Gabby, have you ever done dedicated midwater, like transecting through midwater, that kind
yeah,
of thing?
when we do like a midwater transect, usually we keep the camera exactly that they're doing it like sampling style, like where they're planning to annotate later.
Right.
And
you just fly straight forward, right? Yeah.
Yeah. 1350. I am making an attempt to go a little faster on the vertical. And you're not as interested in inverts, you want the...
Well, I prefer fish, but anything is good.
Okay.
It's better than just sort of cruising through and not seeing anything.
There's a lot of glare on the lens.
Yeah. Oh.
Whoa. What if we point the camera down a little bit more? Yeah. Yeah, still a bunch of glare.
I mean, I can turn off downlights and then we can adjust the...
Ooh, it's a nice fish out there.
Go for zoom. It's really, I'm sure it's really hard to focus.
Really
and
hard.
Yeah, there's just no depth of field at all.
Yeah.
No idea how far away something is.
Couple of things right in the middle.
You want to zoom?
Yeah. Let's just keep like partly zoomed.
Squid.
Ooh. Do not know what that was.
It's not a squid?
Yeah, squid.
Squid, okay.
Yeah, you can keep a half zoom there, video.
Another shrimp.
So the squid are sort of following us.
Yeah, they probably want to hunt in the lights.
Okay, this is... It's about half... I don't want to go too fast here. We're getting pretty close to where I want to even out.
Another suggested shrimp. Ooh, that's a dragonfish on the right.
Oh, cute.
On
I
the
like
right.
dragonfish.
Yep.
It's gone.
It's gone.
Okay.
Okay, I noticed that we're seeing a lot more organisms in this dive than the previous ones.
Oh.
Is there a reason?
Well, we're intentionally looking a lot harder, so we're definitely going to see more. All those little oh, that's...
What are these?
Oh,
What's that?
That,
Oh.
okay. It's a fish, but I'm not sure which one. A lot of the little silvery discs that we see out there could be hatchet fishes, and that actually looks very much like what's called a barracuda. It's like a miniature barracuda.
Oh.
There is a lot here, though, Lottie.
Yeah.
I feel like this is a preview of what we're going to encounter on the seafloor.
Is there current? Do we know that?
Maybe a little bit. At 50 meters, there's about a half a knot of current.
Siphonophore there.
Siphonophore on the left.
Cute.
And whenever you have a
That's
moment,
a lantern fish there.
if you could turn on ROV upper and lower.
Yeah. Thanks for the reminder.
No problem.
What time do you expect to reach the bottom?
In 38 minutes.
38 minutes.
Quick maths.
Is that
Yeah,
mental
I'm
math?
really fast.
Awesome.
Oh. Oh.
Ooh, there's a fish.
That's a hatchet fish right there.
A what fish?
Hatchet fish. See how
Hatchet.
shiny it is right there? They're very,
Oh.
very silvery on their sides, and they almost look like silver dollars. Just kind of twinkling in the background. I'll have to pull up close-up images of some of this stuff.
Yeah, right?
So we're diving after sunset, so a lot of the creatures that kind of hide down lower around 500 meters during the day make a migration every night up towards the surface to feed.
That's true.
That's a hatchet fish right there, Lottie.
Pretty.
Thanks, Jeff.
Yep. But yeah, see that thing kind of out in the middle top? It's
Yeah.
just kind of twinkling and swimming slowly. That'll be a hatchet fish.
You know the twinkles?
Yeah.
Do we know if they use it for hunting or camouflage or?
They use during the day, the really reflective sides is a great form of camouflage. So they're still, if they're living around 300 or 400 meters, there's still enough light. And if they are staying still and a predator looks at them from the side, they reflect the light from above and they disappear into the background with that silvery side. Doesn't work so well when you're shining lights on them.
True. That's a dead giveaway.
Yeah.
Oh, there's this ctenophore right there. It's gone.
So now we're starting to enter what would be normally the daytime depths of a lot of the animals that migrate. Except not all of them migrate
Video,
every
you can push
evening.
past the vignetting.
So a lot of the animals will skip a day and not migrate up to the surface. And people are trying to figure out why that is, why not all of a population migrates every day. A lot of species, almost all the population does. They come up to the surface to feed. And then, of course, there's a bunch of animals, particularly things like fangtooths and dragonfishes, and they just don't migrate. And they wait for the migrators to come back down, and they prey on them as they're moving through the water column back down to their daytime depths.
Oh.
So at this depth, we might see a bunch of predatory eels and things like that, if we get lucky.
And we will. On this watch, we're going to get lucky. Well, welcome to our viewers from all around the world. We have Australia, South Africa, Philippines, Japan, Germany, Canada, India. Wow. Welcome to Nautilus Live. This is your 8 to 12 watch. We just launched our vehicles and we are on our way to the bottom. Our estimated time is about 30 minutes, right, Gabby?
Yeah, 30 minutes.
30 minutes. Our chat box is open. We are now available for questions. Join us as we explore an unnamed seamount south of Angar Island. Expected dive duration is about 16 hours, and then our maximum depth is about 1,351 meters. Yeah, much more shallow than our previous dives.
Yes.
So we're
This is
expecting
going to be
see
very
some...
different than the last few days. Yep.
Awesome. Okay, so team, are you ready for a little bit of introduction to our viewers?
Sure.
Yeah.
Okay, so for the previous dives, the science team started. Does the front team want to start this time?
Sure, we can do that.
Awesome.
Hello, everybody. This is Derek Sowers. I work as the Mapping Operations Manager for the Ocean Exploration Trust. And I am sitting in the navigator seat for this watch for the next 4 hours.
Oh,
Oh,
there's a big siphonophore.
And
Yeah.
to my left is the
I'm-
Hercules pilot.
yeah, I'm Gabby. I am sitting in the Herc seat. I am ROV lead for this cruise. And that's it.
Awesome.
I'm Rye. I'm in the Atalanta seat, which will be the eye in the sky view tonight. And yeah, that's it.
I'm Max. I'm in the video seat. I'm a video intern on Nautilus.
Okay, thanks. My name is Lottie Halleck. I am in the SCF seat, or the Science Communication Fellow seat.
Ooh.
Jeff?
My name is Jeff Drazen. I'm a professor at University of Hawaii, and I'm really excited to be on this expedition. I'm one of the science team leads here, deep sea ecologist specializing mostly in fishes.
Hello, my name is Piera. I work at the Palau International Coral Reef Center. I'm currently on the Nautilus as a scientist, and I am mostly here. I'm mostly collecting water for environmental DNA.
Hi everyone, my name is Noelle. I work as the science coordinator for the Ocean Exploration Trust, and I'm on the 8 to 12 watch as the data logger.
Awesome, thank you, team. So my follow-up question would be, what deep sea animal would you not be, and why? Let that marinate for a few seconds. What deep sea creature would you not be, and why? Because we've been talking about like deep sea creatures would you be, but
I would not be the male of the anglerfish.
oh.
Good choice.
I think for me, I think last time I wanted to be like that shrimp who had like freedom to go around, but now I would want to be in the sponge dungeon shrimp, yeah. Because I think, stability and
Stability.
you're not
Secure
being
home.
Steady paycheck.
Yeah, you're not being actively hunted. Like I think Derek said last time, you're not running for your life
Pension.
in the bottom of the ocean. Yeah, so I think I'm gonna stick
Healthcare.
with that. Yeah.
I missed that, Derek.
We were just talking about the benefits of living inside a sponge. Healthcare, pension. Steady paychecks.
That sounds better than running for your life, you know?
Absolutely, yeah.
Yeah. You don't have mad anxiety.
Sounds better than being a contractor shrimp, I guess.
This metaphor was getting a little too.
Yeah, it's well on the
Getting a
nose
little
for
too
me.
real.
Let's see, we should change the subject.
Okay.
This might have backfired.
They probably pay a lot of
Yeah.
taxes too, I would guess. Us contractors.
Yeah. More so the Canadian ones.
At least you get free healthcare.
I'll leave you with the sun.
What was that? Can you pan left real quick? Oh,
What was that?
I'm not sure.
I think it was, looked like a squid.
Like Humboldt sized, maybe?
Yeah, a bigger one.
Yeah, it looks like a...
So Lottie, to your question, I decided I didn't want to be that fish we saw with the parasites the other day.
Oh,
Yeah,
Oh,
that's
ew,
good.
yeah.
Yeah, I
the
wouldn't want
copper
parasites on me either.
Was it a rat tail?
Rat tail?
It was a rat tail
Yeah.
covered in parasites.
Yeah.
Yeah.
Yeah, it was a bit gross.
I like sea cucumbers, but I definitely don't want to be one. Just walk around and eat mud.
I bet sea cucumbers are like the happiest creatures on this planet, probably.
Again, a pretty
possible.
stable life.
Yeah.
Isn't there a fish that is notorious for living inside the sea cucumber?
Yes.
What?
I don't want to be. I don't want to be that.
That's called a pearlfish.
Yeah, I don't want to be a
Carapidae.
pearlfish.
Yeah, and it lives in a sea cucumber's butt.
Really?
Really?
Yeah.
James said, spit your guts out sometimes.
Yeah.
Who's known for that discovery?
Not me. James is saying for sea cucumbers, and you spit your guts out sometimes. Hashtag best sea cuc life.
Sorry, I just yawned on SPL. It was too much.
You don't have to take credit for those, though, because no one will know who it was.
Blame it on
Probably.
the dog. Just blame your yawn on the dog.
Ah, yes, the dog. No, I think there's a camera looking at me. I think that I've been outed as soon as I start to yawn.
That's correct, Gabby.
Yeah. Thanks.
Just yawning again.
I need to stop talking about it.
Yes, it is. Maybe I'll just turn that off for now.
Well, I think this is going to be a really interesting dive today because we are about 80 miles south of Angar Island, and we're kind of moving into that southwest islands province of Palau. And that's really different than sort of the northern and eastern areas of the EEZ that we've been diving in before. Those areas are really influenced by the equatorial current. And down here, we kind of move into a completely different current regime. It's the equatorial countercurrent at the surface, and it moves the other way. And we're not exactly sure what's going to happen at depth, but we'll find out. Ooh, there's a really cool fish that just went by there. This is going to be probably the shallowest dive that we have done thus far. We will end the dive at about 800 meters on the top of this ridge crest. And that could be really fascinating. It could have really high density sort of sponge and coral communities because of the exposure to flow there. And because it's this shallow, there might also be a bunch of fishes that intercept all these midwater animals that we're looking at right now as we descend through the water column. A lot of what were called midwater or mesopelagic animals, those that live between 200 and 1,000 meters, a lot of which migrate. Sometimes they migrate up at night, and then they end up moving horizontally, and when they migrate back down, some of them to 1,000 meters, they run into topography that wasn't there before because they've shifted their position. And so there's oftentimes a lot of animals on the tops of these shallower seamounts that specialize in feeding on these midwater animals. So that could be really interesting if we see that when we get to the top. Mm-hmm. Many hours from now, but it could be really exciting.
Do you have any expectations from this dive?
A whole lot more corals and sponges, and yeah, a really different community of fish at the top for sure.
I was hoping for some sand.
Max wants sand.
Don't jinx it, Max. I got excited last time. Okay, team, let's manifest gardens, corals, and lots of fishes. And then about 15 minutes in, they called to recover our vehicles. Yeah, so I'm just going to keep that to myself until we safely reach the bottom.
So to our listeners out there, if you did not tune in yesterday, you may not understand some of this conversation. The dive was interesting in some respects, but it was pretty monotonous as we flew over a vast plain of mud for many hundreds of meters. Couple of kilometers actually. So, but I think, ooh, can we zoom on that right there? That was a siphonophore. We only get to have a glimpse of these things. Siphonophore is a gelatinous animal. It's kind of like a colonial anemone in midwater. They're really, really amazing. But this dive yesterday got a bit monotonous, and I actually think that's a good thing because not all of the deep sea is the same, and it's good to visit many different parts of it and get to see the entire variety of ecosystems that exist in Palau's EEZ. It's not all going to be the same, and as many different types of habitats as we can explore, the better off we are, because then we may even have, towards the end of this, with many, many dives, some ability to predict what habitats might look like in different parts of the EEZ that we don't get to explore. Mm-hmm. And that's really useful for conservation planning and thinking about the sum of all the resources in Palau's waters.
Well, speaking how earlier on how hard it is to kind of image as we're descending with this ROV at this speed, there are many of our viewers are probably aware of this, but earlier this year we had Woods Hole's Mesobot vehicle out here and operating off Nautilus. It's a really cool vehicle that's purpose-built to actually explore the water column and kind of follow individual creatures around and get really good imagery of all the life that's living in this layer that we frequently are moving through. And it's not really the right tool typically to try to look at things with a large, loud, bright ROV. So it's neat that there's a new vehicle that's been designed specifically for that purpose, because it kind of is a different application. So we do have some great video footage of what that looks like, what that vehicle is capable of capturing and imaging, and all the amazing sea life that's in the water column, and very understudied actually. So I'd encourage you to seek out some of that and take a look. It's really cool. It also allows us to verify what we often see in the acoustics. So we can see these biological layers in the water column with some of our sonars, not the multi-beam particularly, but we have an EK80, which is more of a water column sonar that's got frequencies that are better to look at things like that. And you can actually see these scattering layers of dense biology. And then with a vehicle like Mesobot, you can go down and verify what you're seeing in the acoustics and actually start to understand what organisms are making up that layer.
For our sonars, I got questions from our young viewers. Does it hurt the organisms, like any fish?
Does the sonar hurt the animals?
Yeah, does the sonar hurt any organisms in the ocean while we're mapping?
Not the types that we're using, no.
Oh, okay.
It's, yeah, we're not harming anything with the activities that we're doing. Everything with sound is kind of like, if you can picture using sound on land where we can hear in our hearing range, how harmful a sound is to something is very dependent on what its hearing range is, like what its hearing abilities are, and the frequency of the sound that they're hearing, and then how intense it is. Kind of like, you know, you can be annoyed by a vacuum cleaner in your house, but it's not really harming you. If you're standing right next to a jet engine all day, it's going to damage your hearing, because it's in a frequency you can hear, and it's at a level that's harmful to your hearing. So it's kind of similar to thinking about sound in the ocean. It depends if that's within your hearing range, how close you are to something, how loud it is. And the types of sonars are very different. So it's not like there's one kind of sonar that does everything. There's many different ones, and they're very different in the way they're designed and the way they propagate sound through the ocean. So we're very cognizant that we don't want to be harming anything, obviously, that we're trying to explore. And we keep track of the research, trying to look at there's been some very careful studies looking at how things like marine mammals will respond when a multi-beam sonar, for instance, is run through an area where they're present. We can listen to their calls, we can look at their dive behavior, and basically you can kind of see if they're trying to avoid the sound or just more like acting normal, which has been the case with the studies that have been done so far with the multi-beams that we've looked at. So a great question. It's not really a simple answer, just because there's so many different types of sounds, and for all the reasons I just talked about.
Oh, okay.
But yeah, the sonars we're using on the ROV, we're not harming anything that we're exploring here.
Do we know what type of sonar we're using on board?
Well, we have a couple different ones. So right now on the ship, before we stopped and put the ROVs in the water, we were mapping with our multi-beam sonar. So that's basically attached to the bottom of the vessel, and it sends out sort of a fan of sound, and that's what we're using to map the terrain. So that's one of our sonars. We have another one that's called a sub-bottom profiler, and that's sending out a low frequency sound that actually shows us like an echogram of the sub-sea floor. So underneath the seafloor, you can see some of the shallow geology layers for areas where like the sediment's depositing in the ocean. So you can geologists like to look at that, and they can infer like some of the structure of the seafloor from that information. So that's another type we use. Then we have something called an acoustic Doppler current profiler, and that's actually sending 4 beams of sound out from underneath the ship. And it's basically tracking how water particles move through those 4 beams. It does a bunch of fancy math, and from that you can tell what the current underneath the ship is doing at pretty much any given layer to the range of that sonar. So we can see like what currents are doing right beneath the ship, 50 meters below us, and then up to 100 meters with this particular sonar. So that's really helpful to know when you're putting vehicles over the water, which way the current's going relative to the ship, so you're not putting something in the water that's going to kind of get swept under the ship. Those ADCPs are also useful for scientists that study like physical oceanography to understand the currents in the ocean and how they move. And so if you want to study deeper current systems, you use one of those instruments, but you might use a lower frequency that can go further. You might have a line, like a mooring that goes down to the seafloor with a weight and actually attach multiple ADCPs, these sonars kind of at different depths in the water column to look at how the currents are moving at different depths. And you can also deploy these looking upward from the seafloor, so you can put them with a weight and kind of looking up to measure like bottom currents. So those are some of the ways those sonars are used. And then on the ROVs right now, we're running some sonars that help us kind of look in 360 degrees around the vehicles, and that shows us things like obstacles that we might want to avoid, or just be aware of where they are, like rocks and steep cliffs, and what's coming up ahead in the terrain. What else do we have? We have an ultra-short baseline sonar. So this is, again, it's at the bottom of the ship. It's a pinging sonar, and it pings to both, well, the vehicles are actually sent a signal down our steel cable that they're connected to the ship with, and they ping from the vehicles up towards the ship. And then the ship has a transceiver that's actually listening for the pings from the vehicle. And it's essentially using like a triangulation method to determine the angle at which those sounds are coming in. And then since we know the depth of the vehicle, the distance away from the ship, and the speed of sound in water, we can calculate roughly how far away those vehicles are. So it helps us position the vehicles underneath the ship. So pretty much the whole dive, we're monitoring that to track where the vehicles are relative to where the ship is. So that's another type of sonar we use. The sonar, the ROVs themselves have like basically a little. It's similar to an acoustic Doppler current profiler. It's called a DVL, and that's instead of trying to look at currents in the water column, it's actually tracking on the seafloor itself. So it's just pinging off the seafloor. So as the vehicle moves, it's a way to assess how quick the vehicle is moving along the terrain, which is really helpful to know for positioning and for the pilots.
You haven't done all the sonars yet. There's still 3 scanning sonars and another multi-beam.
Okay. Wow, that's a lot of sonars.
Yeah, I touched on the scanners.
Oh, did you? Okay.
Yeah.
They're not all used.
Although I still don't know what the Tritech does, so maybe someday you'll explain it to me.
Someday maybe we'll know.
Yeah, I didn't mention that we also have a small multi-beam that's mounted on the front of the ROV. So we can use this. You could fly off the seafloor more like 20, 30 meters and actually make a very high resolution map of the surrounding terrain. So we had that sonar on the other night, a couple dives ago. We were able to map very detailed features. So essentially, the closer you are to the terrain, the more detail you can get in your map. So when we map from the ship, we get a great base map, but it's not very detailed compared to what we can do when you send a sonar down on the ROV and you can map from close up. So you're kind of trading off, like you cover a small area when you're close to something, but you get a lot of detail in the terrain.
Oh, okay. So now I have a question. Like when we reach the bottom, I noticed that some of the eels, the cusk eels, they tend to swim away from the ROV.
We're
Is it
very
from
loud
the...
and bright.
Oh, okay.
It's just like, I don't know, if you're like hanging out in like a dark place and then all of a sudden like a big truck comes by, like just bright lights shining in your eyes, loud diesel engine, like we're just loud and bright.
Mm. So that causes the organisms, fishes to move away. That makes
Some
sense.
of them move away, some of them like the light and come closer. But we're loud and bright. And like, imagine if you're like a creature that never ever sees the light, how bright this must be. If you actually have light detectors anyways.
In some of our baited camera stuff, we use time-lapse videos. So the lights come on and they stay on for a minute, sometimes 2 minutes, and we record video, and then they go off for several minutes. And it's really interesting when we do experiments like that, because typically when we're above 1,000 meters or so, the lights come on and you actually see the fish move away. They are definitely reacting to the light. When you get all the way down to 4,000 meters, oftentimes nobody reacts. But
that's interesting. I've also seen it, I was talking earlier about how you can image the biological scattering layers in the water column, and then I've looked at like a dive time series of that information, and you can actually see when the ROV goes through that layer, some of the organisms sort of move away from it, and then when it gets down deeper through that layer, they kind of reconverge into a solid layer. So there's definitely some avoidance by some of those creatures as well, at least in some of the places we've been that I've seen. I think it's just a temporary thing where, again, they're kind of scared away temporarily. And like Gabby was saying, I think it varies by the organism. Like some are going to do that avoidance behavior, some are not going to be fazed by it, some will maybe be attracted to us. So. But it's something to think about. It's like what we observe in the ocean's kind of always affected by the tools we're using to try to observe things. So we don't want to bias our understanding of what lives there just because of the way we're trying to sample it or observe it. So we have to be thinking about how these tools are changing our perception of what lives there. That's why I think the whole effort recently to do more eDNA work is really interesting, because you're literally sampling the cells of things that you can't see and that are maybe not prone to being something you can see in a video from an ROV, or but they're out there and they're part of the biodiversity of the places we're exploring.
Starting to see beam on Doppler.
And that's certainly not something that's limited to our efforts in the deep sea. I've worked a lot in shallow coral reefs, and the main tool that we use is scuba diving. And it's great, you're underwater, you're in the ecosystem, and yet you still are carrying this tank on your back with this really loud breathing in front of you, which certainly has an impact on the observations that we make and what organisms we see. So this is something that we certainly encounter in science, and we try to choose the right tool for the right job.
Awesome, thanks guys.
Almost there.
Almost?
I'm going to add one more thing to that conversation.
Go ahead.
The eDNA approaches, I think, are going to be really wonderful, but they all require that we have a library against which to compare the sequences that we get. And so a lot of what we're doing here is really important because we're collecting animals, and we'll actually have the physical animal, we will know what it is, can identify it, and then we can sequence its DNA. That's adding to the library, so that when we get a bunch of anonymous sequences that are filtered in water, we know what to match them to.
Oh, that's cool.
Yeah, that's a great point. Doesn't help to gather a bunch of stuff that you don't have any idea what it is.
Yeah, we've done that, Derek, and it's kind of frustrating. You're like, yep, there's 15 species of crustaceans here, but we don't know what any of them are.
All right, 4 beams on the Doppler.
Do you know this paper that James is citing?
What's the range on the Doppler roughly?
Oh, this is a Bellwood paper. I bet you Noel knows this one. It's about biases, subconscious biases in coral reef fish studies. Noel is shaking her head yes. I have not read this one being a deep sea guy, but all fields have biases in their sampling.
Yeah.
Well, welcome to our viewers. If you're just tuning in now, we're expected to reach the bottom in about how many minutes? Guess?
Looks like 2 minutes.
In 2 minutes, perfect.
Stand by.
So stand by with your questions. Explore with us. The area that we're in right now has never been explored before or mapped, so we're pretty excited.
Can I send a reset?
Yes, you can.
Okay.
Oops, that's not the right one. There you go.
Speaking of biases.
Sure.
Yes.
Oh.
What is that?
What? Oh. Oh.
Is that a gulper eel?
Oh, it looked like.
Oh, wow. Yeah, that's what that looked like.
I want to see.
Is it below us?
It's above us.
Above us.
Oh, it's gone.
And there's the bottom.
I have never seen a gulper eel in person. That was super rad.
Yeah.
Yeah.
I was just thinking yesterday about how cool it would be to see a gulper eel. Oh, I'm thrilled. Yeah, you're fine at 30. I'll keep coming down.
Great things are coming.
Nav, what's going to be our direction of travel?
Stand by a sec. Hundred. 100.
Okay.
What's happening?
No idea.
She's just cracking herself up.
Yeah.
By yourself. Well, it's not sand.
That's good. That's a good sign.
So I'm just going to stick close to the bottom. I'll keep backing down until you have enough tether to turn around with.
That's a giant clamshell?
Oh, what the hell would that be doing
Just
here?
a shell? Or maybe just drift down.
Oh, that?
Like, yeah.
Go for zoom video?
Yeah, it is.
That's a giant clamshell.
It's a giant
Well, it's
clamshell.
at least a clamshell, but With that fluting on the edge, it's got to be
Yeah,
a giant
yeah,
clamshell,
it's a
yeah?
giant clam.
Wow.
Go wide.
Very out of place here.
Fish.
Fish
Where?
on the right?
Oh, yeah.
Halosaur.
That's what it looks like.
Go for zoom.
That's
Tiny
not
one.
a halosaur. Nope, something else. Cutthroat eel.
Okay, everything's going to be bouncy until we get ourselves set up properly.
Sure.
So
No
go wide.
worries.
But you've affected me. You've infected me. I now, like, every time I see a fish, I'm like, well,
Success.
who needs operational stability in your ROV when you can look at fish? There was a time when I would have said, not right now.
One of us.
That's kind of freaky.
Okay.
Just let me know when you want to move.
Okay.
What's going on with that camera?
Oh,
I don't
guys,
know.
whenever you're ready, can we trigger an skin, please?
Yep.
Since we're at the bottom.
We lost butt. And something else.
What's going on with Atalanta?
I don't know. You've got no comms with Atalanta. Okie dokie. Okay. I'm coming up. I need USBL because we're no longer going to have Delta.
Copy.
Okay, I do have Delta. Are you coming up right now? Okay. Okay, sounds good. What am I getting Delta from? Can you, yeah. Am I not getting any USBL from Atalanta right now? Can you switch it to transponder mode?
Yep.
And can you stop coming up? I'm going to hold depth because I don't really know what's happening right now.
Do you want me to keep Herc the way it is or change that one too?
Nope, keep Herc the way it is.
Okay, it's back.
Okay, can you give me back DVL nav?
Yep.
Okay, I can see Atalanta and butt cam. We're gonna have to do this just by speed. So I'll start by setting a speed up of 15. Yeah, go for it. Okay.
Is there anyone you want me to go get or notify?
We need to just start the process of letting people know that we're recovering the vehicles. Lost comms with Atalanta.
Okay.
So that's going to be Daniel needs to know and Mike needs to know.
Roger that.
So it looks like right now I'm coming up at about 10 meters a minute. Are your thrusters on right now? Okay. Right. Next thing, let's look at the, let's see, 10 meters a minute. You've got 10 meters a minute. I'm going to start thinking about troubleshooting a little bit. If you can do me a favor and fly the butt cam, I'm going to give you a better view here too. Dive salvo coming up. Okay, so I'm coming up at 10 meters a minute right now. You have everything you need to keep moving? Okay. Okay. Yeah, I'm gonna test my group too. Yeah, it's just we don't have any comms is what that means. Yeah. Okay, if you're comfortable, I can try speeding up a bit. Do you think you can track it?
Noel, did you catch the off-bottom time?
Yes,
And did you put it in C-log?
I did.
Okay, thank you. So yeah, just an update is we're having an issue with Atalanta that we're troubleshooting right now, and that's why we've moved off the bottom.
So we have no power issues anywhere in the system right now, which to me means this is just a comms issue. There's no ground on the umbilical, which we see on the 60 hertz cabinet there. Not even the suggestion of a ground. No change in current draw, nothing. This looks like just fiber. We can power cycle the topside mux. Is the only thing we can power cycle. Yeah, go for it. Hold on one sec, Dan's up here. Hey Dan, you want to power cycle the focal?
All right.
No lights, no nothing. What's that? Yeah. Okay. Very nice. Yeah, we will. Thanks, Ken.
Yeah, so just an update. After some additional troubleshooting, we are going to move forward with recovering the vehicles, and we're going to need to fix that issue with Atalanta. Are we going to want to maintain this ascent speed? I can put it on here if you like. Would that be helpful? Okay. Yep. Yeah.
Uh-huh. It happened on launch? Okay, cool. Okay, cool. I don't know what those errors mean, but if that's like a dropped frame, that could have been sort of a canary. But there's not, like, it's not something that that anyone could expect you to, like, see and be like, oh, stop everything, like, oh, I see. Okay. I like the idea of getting to 20 meters a minute and holding there. How does that sound to you? Our delta is 0, essentially. Thanks, Derek.
Yep.
If you need to bop away from that screen, that's
No,
totally fine.
This is good. I was just wanting to know what the surface currents are doing.
Nice, okay. You can go a little bit faster. It looks like just the tiniest bit. It looks like Herc's overtaking just a little bit. maybe a -1 delta right now. We've got 50 meters to the surface, 50. What's up? You're looking at me funny.
50 meters?
Or 50 minutes, sorry.
Oh, okay. I was like freaking out for a second.
Sorry about that. That's sometimes the only way I know what words come out of my mouth is by looking at people's faces and they're like, what are those words you're saying? They sounded reasonable to me. Yeah.
Bridge, nav. We've got an estimate of 50 minutes until we reach the surface. Thank you.
So you don't have a delta, you just have 2 depths. Your delta is 2. Delta's still 2. Nice job. Delta is 3. Delta's still 3. So Derek, the only sort of challenging section of this recovery, because we don't have Atalanta, is the time between seeing Herc on the surface and losing, or the time between losing USBL and seeing Herc on the surface. So usually I fly that off the butt cam.
Okay.
If we're moving ahead, usually Herc stays just fine.
Yep.
Everything's good. I don't anticipate a problem, but if we're getting swept off to a side or another, I don't know, we just need additional sort of awareness about which direction Herc might be going.
Okay. Yeah, we'll just have to have good comms with Mike and make sure he has eyes on it when it gets up.
Yeah.
Looks like on the DP, the currents and the wind are in tight alignment. But the ADCP does show a current more like this.
Okay.
So we might, once we get to the surface, if Herc is swinging out to starboard, we might have to track a line like 30 degrees offset to help us swing it around. But we can see how it's doing.
Yeah. On launch, the surface was placid. And it was no effort to stay in place behind the A-frame.
Okay. Yeah, so I would expect that we don't need to do that, but
Yeah, okay, sounds good.
just as a backup plan.
Cool.
See, we get good sunrises in New Hampshire. Yeah, it's good surf. That's one nice thing. I do miss sunset surfs on the West Coast, but sunrise. Yeah, that's what that was from. Yeah. Yeah, I mean, y'all have already put in a long day. Last 24 hours. bridge, nav. Could we start streaming forward at 0.3 knots, please? Thank you. And if we could just confirm that the tanks are secured and enable the air tuggers, please. Thank you. Go ahead, Bridge. Thank you very much.